Graphing quadratic functions. Quadratic function is like using an equation a equals s squared. That's saying that the area is equal to side times side. That would be an example of a square. What you'll see is more likely is y equals x squared. When x is squared, it's going to create a quadratic function or a U-shaped graph that can open upward or downward. It'll open upward and downward depending upon the coefficient in front of x. When this coefficient is positive, the graph will open upwards. So upward positive, and it would be downward when it's negative. So when this coefficient is positive, opens up. When it's negative, it opens down. Here's the equation that we have given. Y equals 5x squared. Again, the x squared is indicating that it will be a quadratic function. This 5 is telling us this graph should open upwards because it's positive. So we're going to go ahead and set up a table in order to go ahead and graph this problem. They give us values for x, so we'll substitute in for x. We have in for x here. We have -2. Remember, use that set of parentheses for substitution. Now, when you solve this problem, you have to follow order of operations. So you need to take care of your exponent first. -2 is being squared. -2 times -2 is 4. Negative times a negative is a positive. So we have 4 times 5, which is going to give us 20. We need to go ahead and fill in the rest of our table and solve. When we go ahead and solve for y here, the second example, we have -1 squared is 1 times 5 gives us 5. Here's what the rest of our values would be. The next step, I would like you to go ahead and list off this as an ordered pair, because this will be a plot on the graph. So I like to list these off so they're easy to take and go ahead and plot. So there's my 5 plots for the graph. When I look at my graph here, notice that there are no intervals here. That's saying that everything is going up by ones. You'll want to change that. Look at your y values. You have you have 20 that you need to get to. So I need to get all the way up to 20, and my lowest y value is 0. Well, I can get there by going up by maybe intervals of 4. Then I can get up to 20. Now if you look at your x values, it goes from -2 to 2. So I'm going to leave those as intervals of 1. Next, go ahead and plot -2, 20. There it is. -1, 5, slightly above 4. We have 0, 0, 1, 5, and 2, 20. There's your plots. Look at that. It's going to create a nice U-shaped graph with that smooth curve, curving upwards because 5 was positive. Another way to check this is I also have a link on the Moodle site. So if you look on the Moodle under MCA Prep, there's a spot there that says MCA Interactive Calculator here. Right at the top, go ahead and click that link and you'll have the calculator that actually you use on your MCA test. So it's good to go ahead and become acclimated to that calculator for the test. When you pop it up, here it is. More than likely it's going to be in the scientific format. You need to get into the graphing format. The graphing will help you show you what the graph will look like. So if I look at this first one here, over there we have y equals something. Well, the equation that we had was 5. We have x var. X var is going to give you your x. And then we know that x is squared. So we have the squaring component down there in the bottom right. There's the equation. Next, we're going to go ahead and graph it. So I'm going to hit the graph feature. There it is graphed. Much like your graph that you have on your piece of paper. So just a way to double check on what your graph kind of would look like. Example 2, if we check this out here, this should curve down because of the -4, that coefficient out in front of x squared. Still going to create a parabola, so we'll go ahead and fill in the table. Once you have your table filled in, follow order of operations, take care of that exponent. So the first one, we have -2 squared is going to give us 4. 4 times -4 is going to give us -16. Fill in the rest of the values when you figure out values for y, which we would get -4, 0, -4, and -16. Go ahead and write them as an ordered pair. There's my ordered pairs listed off. Use the graph. The graph here, again, we're going to have to change the intervals up. We have to get all the way down to negative 16, so I'm going to go by 4s again. So I'll start here with negative 4, negative 8, and there's my negative 16 that I need to get to. X values are not going to change from negative 2 to 2. I can go ahead and hit that on my graph. So go ahead and plot. There's my values plotted. Next, go ahead and create that smooth curve. There it is. There's that quadratic graph. And again, you can go ahead and check that out if need be with that graphing calculator. Go back to your expressions here, and maybe I'll go down and construct that new graph that we have of negative 4x squared. So here's that equation. You're going to use the minus sign as a negative, and we had 4x squared. This graph should curve down, and it does. We still have that other graph up there in the equations here, that 5x squared. So you have two graphs graphed on there. Example 3, I'd like you to go ahead and do the same thing, solve. The only difference here is that we see that this is positive, graph should curve up. Now we're adding 1, so we're going to see what happens when you add 1 to the graph. There's everything substituted in. Follow order of operations for the first example. Negative 2 squared. Negative 2 times negative 2 is 4. 4 times 3 is 12. 12 plus 1 would give us 13. And we'll go ahead and fill in the rest of the values there for y and write it as ordered pairs. There's my y values. There's my ordered pairs on my graph here when I check it out. My y axis, I need to get up to 13, so maybe I change something up here, and I'm going to go by 3s to get to 13. There's 12, and then we'd have up to 15. Go ahead and do your plots for the graph. And then again, you might just have to get a ballpark because you notice that 13 isn't right there. However, we do know it's slightly above 12. So when I do negative 2, 13, here's 13 is about right in there. Negative 1, 4, and we'd have 0, 1, 1 negative, or 1, 4, and 2, 13. There's my plots, again curving up. Here's that quadratic graph. The only thing that happened here is when you added 1, if you look, it is no longer at the origin. When we added 1, it shifted up 1 unit. So by looking at example 4, we should be able to determine what this graph is kind of going to look like. Well, it should curve down because it's negative. Now we're subtracting 2. In example 3, we added 1, it shifted up 1 unit. So if you subtract 2, more than likely this will slide down 2 units. So we're going to go ahead and fill in the table. A little tricky here, when you fill everything in here, if you look at it, here's that negative sign. That negative sign is carried all the way throughout that table. So I'm going to take care of order of operations, take care of my exponent first. Negative 2 squared is 4. Well, then we add that negative to that positive, so we have a negative 4. And then we subtract 2 is going to give us negative 6. Filling in the rest of the table, we have negative 3, negative 2, negative 3, and negative 6. We're going to go ahead and write these as ordered pairs. There's our ordered pairs. On our graph here, we don't need to get anywhere. Our lowest value there is negative 6, so I should be able to use this whole graph going by intervals of 1s. So I'll start by plotting these points here. Here's what the graph should look like after done plotting. Again, creating that quadratic function, that smooth curve. Notice it did drop 2 units from the origin when we subtracted by 2. Realistic example, it says gravity, the function d equals 4.2 t. This should be t squared. Describes the distance in d, the meters that a rock falls from a high cliff during t time. Graph this function, then use your graph to estimate how long it would take a rock to fall 400 meters. You get to come up with the values of t for time. That's what you're substituting in for into this equation. You wouldn't have a negative time, so I wouldn't start with a negative time. Maybe start with 0, 1, 2, 3, and 4. Small numbers, easy to work with. Plug it into your equation. There's that table filled in. Do your computation. take care of your exponent first. So 0 squared is 0. 0 times 4.9 is going to give us 0. Here's the ordered pair. At 0 seconds, the distance dropped or traveled is going to be 0. At 1 second, it is going to be 4.9 meters would be your distance. At 2 seconds, it will be 19.6 meters fallen. So fill in the rest of the table. There's my tables. Ordered pairs are listed. Looking at the graph here that you have, we'll probably need to title the graph. I have it falling rocks and gravity. Now you have to title your axis. Well, the y-axis and the x-axis. They give you the equation d equals 4.9 t squared. Well, we know that this is normally y equals 4.9 and x is squared. So x is in relationship to d, which is distance. Or sorry, y is d distance and x is t time. So that's what we'd want to label the axis. There's our time in seconds. So I'm going to go ahead and start by going ahead and plotting some of these points in order to plot them. Well, if you look at your time, your x values are going by 1, so I'll have my x-axis go by 1. So there it is, graphed and going by 1s. Reminder, in the question here, we have to figure out when the rock is finally going to fall 400 meters. So I have to at least get up to 400 meters for my y-axis. Looking at this graph here, I'm going to probably go up by 50s. So there's my y-axis going by 50s. It looks like it's going by 100s, but remember, we got to count every line. So there's 50, and then 100, 150, 200. Plot your points from your table. So we had 0, 0 was the first plot. There's my first plot. Then we had 1 and 4.9. Here's 1. 4.9 would be way down below. 2 and 19.6, so slightly above that. 3 and 44.1, so getting close to 50. And then we had 4 and 78.4, so we need to go slightly above the halfway marker here. In between that is 75. So there's my curve that is starting to happen. And if you continue that curve at this rate, it's going to eventually just keep coming off that paper. Remember, we need to figure, well, when is it going to finally meet 400 for that drop? Well, I carry over according to my graph. It's about right in there, so that it would cross 400. So I'm going to say that it's about 8 seconds that I would put down for that distance to drop 400 feet. So it's an approximation using the graph. This will conclude 10.2 graphing quadratic functions. So we need to put in 8 seconds.